All right, let's dive right in. Today, we're going to get our hands dirty, so to speak. We're going to take a brand new network switch, literally fresh out of its box, and walk through all the essential steps to get it from a piece of hardware into the heart of your network. Let's get to it. So picture this. You've got this shiny new switch sitting on your desk. You plug in the power cord, the lights start blinking, and then what? What's next? Right now, that box of blinking lights is just a box. It's got all this potential to be the backbone of your network, but it doesn't know what to do yet. It needs a brain. It needs instructions. And that's exactly what we're here to do.
And this is it. This device right here, or something a lot like it, is one of the most fundamental parts of pretty much every network on the planet. But, just like it says right now, it's a complete blank slate. It's got no identity, no purpose. So over the next few minutes, we're going to give it all of that. We are literally going to bring this thing to life.
So the very first thing that happens, the moment you plug it in and give it power, is the boot sequence. This is a whole series of internal checks and processes. I like to think of it as its spark of life. Let's take a look at what's actually going on under the hood during those first few seconds.
The second it gets power, the switch runs through this really important 5-step process. First, it does a power-on self-test, the post. Think of this as the switch waking up, stretching, and making sure its brain, its memory, all the important bits are working. Then it loads a tiny program called the bootloader. That gets the CPU and the file system ready. And then comes the grand finale. It finds and loads the main operating system, the Cisco iOS. That's the real magic, the software that gives the switch all its smarts.
So how do you know all this is happening inside a metal box? Well, you gotta watch the lights. These LEDs on the front are kind of like a secret code, and this chart here is our decoder ring. The one you really want to watch is the system LED, usually labeled SYST. Seeing that light go from flashing to a solid green means that whole boot process we just talked about went off without a hitch. It's the switch's first way of telling you, hey, I'm okay.
Okay, so the switch is booted up and healthy. Great. Now, we need to give it an identity so we can actually talk to it and manage it over the network. Because, let's be honest, you're not going to stay physically plugged into its side forever, right? To do that, we need to give it an IP address. It's just like a house needing a street address so it can get mail.
And the way we give it that address is with something called a Switch Virtual Interface, or SVI. Now, this is super important. An SVI is not a physical port. You can't plug a cable into it. It only exists in the software. The best way to think about it is as the switch's own private phone number used just for management. It's how you, the network admin, can call it up and tell it what to do.
So, to assign that management phone number for the very first time, we have to make a direct connection. We use a special console cable, just like this, to link our computer directly to the switch's console port. This gives us a direct line to the switch's brain, the command line interface, so we can set it up before it even knows what a network is.
Once we're connected, we use these commands here. First, with interface VLAN 99, we create that virtual interface. Then, we assign it an IP address and a subnet mask. Now, this next command, no shutdown, is absolutely critical. It's what actually turns the interface on. And finally, you save the configuration, so all your hard work doesn't disappear the next time the switch reboots.
There's just one more piece to this identity puzzle, the default gateway. If the switch needs to talk to a computer on a different network, say your PC across the office, it needs to know how to get there. The default gateway is basically the exit door for the network. The GPS analogy here is perfect. It's how the switch finds its way around when it needs to go somewhere new.
All right, our switch has an identity and can be managed remotely. Awesome. The next big job is to configure the physical ports, the actual jacks where we'll plug in computers, servers, and other devices. We need to lay down some rules for how they're all going to communicate. And one of the most basic rules is the duplex setting. The difference here is, well, it's night and day. Half duplex is like a narrow one-lane bridge where traffic can only go in one direction at a time. It's slow and inefficient. Full duplex, that's a massive multi-lane superhighway. Data is flying in both directions at the same time, no waiting. For any modern network, you absolutely want that superhighway.
So how do we guarantee we get that superhighway? We set it manually. Now, most devices try to figure this out on their own using something called auto-negotiation. But you know what? Sometimes they get it wrong, and a duplex mismatch can absolutely cripple your network performance. So for important links like the connection between two switches, it's always a best practice to lock in the settings. We just select the port and tell it you will be full duplex and you will run at 100 megabits per second. No arguments.
And this right here is the result of those commands. We've just created a stable, predictable, high-performance link between switch S1 and switch S2. We built that data superhighway, and now traffic can flow freely between them.
So we've typed in all the commands, we've set everything up, but are we done? Nope, not yet. In the world of networking, you never just trust that things worked. You always verify. This is our final health check to make sure everything is running exactly the way we planned.
One of the best commands for this is show IP interface brief. It gives you a really quick, clean summary. And if we look at the output here, you can see our virtual interface, VLAN 99, and yep, there's the exact IP address we assigned to it. That's our proof. The management interface is up and running.
Now, for checking a physical port, we'll use show interfaces. This gives you way more detail, but the first line is key. If you see up/up, you're golden. The physical link is good, the software side is good. If you see down/down, seriously, 90% of the time, you just need to check your cable. But if you see up/down, that's your big clue that there's probably a configuration problem, like that duplex mismatch we were trying to avoid. This command is your #1 troubleshooting tool.
So there you have it. We took a switch from being a simple box of electronics and turned it into a fully functional, intelligent member of our network. It has an identity, its ports have rules, and we've verified that everything is working just as it should. We brought it to life. But that brings us to one last really important question. The switch is online, that's great, but is it secure? Now that is a whole other conversation. Thanks for joining me.